When we talk about concentration of solutions, we're talking about the mass of the solute in grams. Okay, so you'd measure the mass on a balance of some sort and you'd get an amount. Okay, an amount in grams. And that is divided into the final volume of the solution. Because if I say that I want to have a concentration of 50 grams for every 1 liter of solution, if I add 1 liter of water, okay, so if I've got my beaker here, and this is 1,000 milliliters, which is equal to 1 liter, if I've already got that much water and I dump in, okay, 50 grams of powder, what's going to happen to that volume? It's going to go up. And that's not what I'm looking for. I am looking for a final volume of my solution to be 50 grams per liter. So this is why you see here the word final volume. Okay, the final volume is not the amount of liquid you add. The final volume is, it takes into account not only the volume of the liquid you've added, but also the volume of the solute that you've added to the solution. So if I wanted to make a solution that was 50 grams for every 1 liter, and I was making 1 liter, I would start off by massing out my 50 grams of solute and I would put it in my beaker. Then I would add a little bit of water, okay, and I would mix it up and dissolve it. And then I would slowly raise my actual water until it reached that final volume that I was looking for. Because if you reach that final volume of 1 liter, you've not only incorporated all of the solute that you need, but you also have all of the actual volume that you need to make that concentration. Okay? So, let's get back to my original question. If I have a concentration of 50 grams for every 1 liter, okay, so if I have my concentration is equal to 50 grams per 1 liter, but I'm telling you that I only want you to make 100 milliliters of solution. Okay, so I want my final volume to be equal to 100 milliliters. Well, for sure, I am not adding 50 grams of powder to that. Okay? That's way too much. But I have to figure out how many grams of powder I'm going to need to add so that I can get that final concentration to be equivalent to 50 grams for every 1 liter of final volume. What this little problem here is asking us is it's saying we already know what concentration we want. We want to have a concentration that is equivalent, that is equal to 50 grams of solute for every 1 liter of solution. But let's say I'm carrying out an experiment. I don't need 1 liter of solution. This stuff costs a lot of money to buy, this substance, so I want to make a small amount so I don't waste it. I only need 100 milliliters, but it has to have the same concentration. So what you end up doing here is you make a ratio. When you're dealing with concentrations, it is nothing more than a ratio. And there should be 4 variables in your ratio, 3 of which you know, 1 you don't know, and that's what you solve for. So if you set that up, it looks like this, where you have 50 grams of solute in 1,000 milliliters of solution, or 1 liter. Seeing as I'm looking for milliliters here, I figure I might as well have the same volume in both of my fractions. So we're speaking the same language. And this is going to be equal to an unknown amount of solute in 100 milliliters. I have 4 variables here. Okay? 50, 1,000, question mark, and 100. And I can cross multiply here in order to find my unknown. And when you cross multiply, I am going to do this the long way. Okay? I'm going to show all my work. When you cross multiply, you end up with 1 unknown, 3 knowns, and you can rearrange that equation for that unknown. So if we're going to cross multiply, we're going to multiply 50 grams by 100 milliliters, and then we're going to multiply 1,000 milliliters by our unknown. Okay, the red stuff is going to be on one side of my equal sign. The green stuff is going to be on the other. So if we want to isolate the x here, what we can do is we've got to get rid of that 1,000 milliliters. And we know from basic math that if 2 variables are multiplied, okay, the only way to get rid of it is to divide. And if I divide on one side of the equal sign, I must do the exact same thing on the other side of the equal sign. So let's get that done. Divide this by 1,000 milliliters, and then divide this by 1,000 milliliters. Okay, my milliliters cross off. I'm left with x. And if I work this out, I want to see what else is going to end up crossing off here. Ultimately, I'm looking for a mass. I'm looking for an amount of particles or juice crystals or whatever that I'm going to add to my, to make my 100 milliliter solution. So this is kind of great. I know that I'm looking for a mass. Look at this, my milliliters cancel out, and I'm left with grams, which are the unit for mass. So putting your units in here acts as a proof that you've actually done the proper math. Had I actually not done that right, I wouldn't have ended up with the right units. And that's a surefire way to know if you've done this properly or not. So you can look at this, and if we multiply, that ends up being 5,000, gram milliliter over 1,000 milliliters, right? Which ends up being equal to 5 grams, which is equal to x. So this means that if I'm going to make a much smaller amount here of my solution, I'm going to use a much smaller amount of powder, and I'm going to bring that up to my 100 milliliter final volume. And these two solutions should have, or they do have, the exact same concentration of 50 grams per liter, even though you haven't made a liter. Okay, they have the same ratio. They've only basically chopped it off, or they've put 1/10 of both of these substances. Okay, 1/10 of 50 is 5. 1/10 of 1,000 is 100. So that's like saying 50 grams in 1,000 milliliters is the same thing as saying 5 grams in 100 milliliters. Okay? You've just played around with concentrations. And if you understand how to cross multiply and to solve for that unknown, you should have no problems doing PPM questions, because that's all it is. You're making a ratio of something you know is going to be equal to an unknown amount of something in a different volume. and you're just equating them. You're making them equal to one another.